Let's go to reinforcement learning. I know you have a passion and a history with not just AI, but AI with gaming, right?
Yeah, especially Go. I'm a Go player.
Oh, and you're a Go player yourself. Okay, I don't feel like I'm smart enough to play Go, but that's good for you. So reinforcement learning had this amazing moment based on, I think it became part of the public consciousness when DeepMind published some of their research around training agents based on originally Atari simulations, right?
Oh yes, originally, yes, yeah. That impressed me already, and later on came the Go thing where nobody expected it to happen.
Yeah, AlphaGo and then AlphaZero later. Yeah, amazing moments. So my question for you is, a lot of people think that RL has already had its day. RL obviously, conspicuously has challenges around complexity, but also sample inefficiency. So my question for you is, do you think it indeed is a thing of the past, or do you think we're going to see a resurgence in reinforcement learning, right? Will there be a new day for reinforcement learning in the future?
Yeah, so the difference between LLMs and deep reinforcement learning is that deep reinforcement learning is not the simple motor. It's rather like a fusion reactor or something.
Right.
It's really a difficult thing to do
much more complex.
To do at all and to do well. So much more complex right now, right? And so applications will not sprout as they do with LLMs.
Yeah.
Unless we find some combination, something that is easy enough that people can use the power of DeepRL also in combination with other models.
Mm-hmm.
But it's not over, and DeepRL is probably going to surprise us in many more ways. When we had this Go thing, everybody said, wow, that's impressive, but are there any practical uses? And suddenly you had AlphaFold, and medicine has changed.
That's a great example. Right.
Yeah, and they have done very impressive things in the meantime, which have not gained the public, not so many publications in the meantime. So, they improved matrix multiplication. So that's a very important general math technology to run any kind of neural network. You need matrix multiplication to run
obviously
neural networks. Yeah. So, and they improved it to make matrix multiplication faster than all the scientists did before. Then the next thing is they have just found, just before Christmas, Google has discovered 300,000 more crystalline materials, which are stable and can be synthesized.
Yeah.
So and that is. That's something that would have taken decades to do with traditional computing, and with deep reinforcement learning, they suddenly could do those things because the computer found strategies to do this.
Right.
Yeah. So, and I assume that if you combine these things one day, so I think Google is probably working on the combination of LLM and DeepRL. So you have like an LLM expert that knows how to handle the DeepRL.
Right.
Suddenly it will open to many other applications like business strategies or anything else.